Hello and welcome to Maths by SAS. This is my fourth lesson of D1 chapter number 9 exercise 9b, that is about the basic concept of rate. In this class students will be learning and discussing basic level question number 6, and let me read the question from the book as the questions are long, so I will be reading the question from the book. Question 6 says that 200 gram of the fertilizer is required for the plot of land that has an area of 8 meters square. 200 gram of the fertilizer is required for the plot of the land that has an area of 8 meters square. That means that for 8 meters square we need the fertilizer 200 gram, or how can we understand the same thing, that for 200 gram we can use 8 meters square area. In the first part, the amount of the fertilizer needed for the plot of the land that has an area of 14 meters square. In the first part, we need to find the how much fertilizer will be needed if the instead of 8 meter square area we have 14 meter square area. And the second part says the area of land that can be fertilized by 450 grams of the fertilizer. The question has two parts, so we'll talk about each part one by one, and we'll be discussing each part one by one, and I will go really slow in these all questions because these questions are really important for your O-level examination. So try to understand the question that if we have 200 grams of the fertilizer, the area is 8 meters square, and we need to find the fertilizer for the area which is 14 meters square. 14 meters square. So what we can do is that if the area is given area is 8 meters square, 8 meters square. Suppose this is a piece of the land that has the area. What is the area of this land? 8 meters square. And how much fertilizer is needed? 200 gram of fertilizer is enough for 8 meters square, and fertilizer needed is fertilizer required or needed, you have to learn the alternative statements as well, is 200 grams. 200 grams, and we have to find the amount of fertilizer for area 14 meters square. Amount of fertilizer which is needed for 14 meters square. So for 8 meters square, fertilizer needed is required or needed is 200 grams. Let me confirm, this is 200 grams. Yes, 200 grams for 1 meter square. 1 meter square fertilizer needed, required is what we are going to do, that we have to apply unitary method. 200 divided by 8 grams, and how much new area is 14. If the area has become what? 14 meters square. 14 meters square, then how much fertilizer you are going to use for 14 meters square? Fertilizer required equals to 200 divided by 8 multiplied by 14. Now is the problem for the cancellation and calculation. So let's try without calculator, and this is 2 4s are, and 2 7s are, and then 4 1s are, and 4 5s are, 0s are, which is equal to 50 multiplied by 7, which is equal to 350 grams. So it means that for 14 meters square we need the fertilizer 350 grams. Now the second part says that the area of the land that can be fertilized by 400 450 grams of the fertilizer. Now the second part says that we need to find the area of the land. Area we do not know, that can be fertilized by 450 grams of the fertilizer. Now try to understand the question, that here we are given with that if area is 1 meter square, then we need the fertilizer, that is 200 by 8. This will give me the simplified answer, 8 ones are 8 twos are 16 and 8 fives are 25. So it means that for 1 meter square area, okay, if the area is 1 meter square, how much fertilizer do we need? That is 25 gram. And now if for 1 meter square we need 25 grams, for 450 gram, how much area is needed? That is the problem in this question. So what we are going to do is that for 200 grams of fertilizer, area equals to 8 meter square. For 1 gram of fertilizer, area will be equal to, we'll be applying unitary method, 8 upon 200. And now the weight of the fertilizer is 450 gram. For 450 grams of fertilizer, area will be equal to what? So 8 over 200 multiplied by what? 450. Now focus your attention that how am I making the calculation easy? 2 fours are and 2 fives are, sorry, this is 2 fours are and 2 tens are, 2 twos are and 2 fives are, 5 ones are and 5 nines are, and we are left with 2 multiplied by 9, which is equal to 18 meters square. Students, you can see that I am not only solving the questions for you, but I am giving you the tips and tricks that how to understand the question by applying CPA approach, and plus I am giving you the idea and hint how can you make your calculation easy without calculator, because all those students will be going for their O-level examination, their paper 1 will be without calculator, so they should have the good practice on how to perform the calculation mentally. And moving to question number 7, which is also one of the important questions of your O-level examination. So let's first try to read and understand the question. Question 7 says a piece of metal is heated to 428 degrees centigrade before it is left to cool. Okay, the first thing is that we are heating some metal piece and the temperature has reached to 428 degrees centigrade, and then we are giving this piece of metal rest to cool down. The temperature of the metal falls at the rate of, okay, now this is the important part that we need to understand, read and understand, at the rate of 23 degrees centigrade per minute for first 3 minutes. That means that for first 3 minutes the metal piece is cooling down at the rate that for every 1 minute in first 3 minutes the temperature is going down 23 degrees centigrade at the rate of 15 degrees centigrade per minute for next 15 minutes. Okay, for first 3 minutes the temperature is going down with the rate 23 degrees centigrade per minute, and for next 15 minutes the rate is going with 15 degrees centigrade per minute, and then at the rate of 8 degree centigrade per minute until it reaches the room temperature of 25 degrees centigrade. The temperature of the metal after 9 minutes, this is the first requirement of the question, and the total time needed for the metal to reach the temperature of 25 degrees centigrade from 428 degrees centigrade. Question has many things to understand, so we will discuss each part one by one. One of the most important questions of your O-level examination. So, let us make some diagram to understand the question. That there is a metal bar or metal piece, and the initially when we were heating it, so the temperature was 428 degrees centigrade, and after that this metal bar we are keeping to cool down. Okay, and then what is the rate given? Rate is given that for first temperature falls at the rate 23 degree centigrade per minute for first 3 minutes. For first 3 minutes, first 3 minutes, the temperature is falling at what rate? 23 degrees centigrade per minute. Per minute, what does that mean? That in 1 minute, the fall in temperature is in 1 minute. Okay, this is 1 minute. First 3 minutes, and in 1 minute temperature is going how much down? 23 degree centigrade. Okay, falling, as this is falling, so I am putting minus sign, reducing. And for next what? Next 15 minutes, first and next 15 minutes, what is happening? That it is falling 15 degrees centigrade per minute. So, for first 3 minutes and for next 15 minutes, I am trying to use CPA approach as well. Okay, 15 degrees centigrade in 1 minute. Initial temperature was 428 degrees centigrade. Then the temperature is falling at the rate for first 3 minutes 23 degree centigrade in 1 minute, and for next 15 minutes it is 15 degrees centigrade in 1 minute, and the next portion says, and then at the rate of 8 degree centigrade per minute. For next is 8 degree centigrade per minute. Okay, and the first requirement of the question is until it reaches to what? 25 degrees centigrade, which is the room temperature. The first requirement of the question is that we have to find the temperature of the metal after 9 minutes. Temperature of metal after what? After 9 minutes. So, let us try to understand the question. That for 9 minutes, let me make some diagram here. I am using CPA approach because in this way question becomes easy for most of the students. That this 9 minutes, in these 9 minutes, for first 3 minutes, the rate is 23 degree centigrade per minute. Okay, and 3 plus 6 minutes, 6 minutes. So, what we are going to do is that for next for the time which is after first 3 minutes till 15 minutes, the rate which is given is 15 minutes, 15 degree centigrade per minute, 23 degrees centigrade per minute and here again per minute. Now it means that 9 minutes are equal to 3 minutes plus what, students? 6 minutes. So first we are going to find out the temperature in 3 minutes. Loss of temperature in 3 minutes. 3 multiplied by what is the rate given? 23. 3 times 3 is 9, 3 times 2 is 6, 69 degrees centigrade, and loss of temperature in 6 minutes. Temperature in 6 minutes. And what is the rate? Rate is 15 degrees centigrade. Okay, 6 multiplied by 15, which is equal to 15 times 6 is 90 degrees centigrade. So total loss of temperature in 9 minutes. What we are going to do is that we are going to add 69 and 90. This is degree centigrade, and this is 9 and 1 10 and 5 15 159 degrees centigrade. So this is the total loss, and the question says the temperature of the metal after 9 minutes. So the temperature of metal after 9 minutes will be equal to 428, because this was the temperature initially when cooling was started. So I have to take away 159 from there. Okay, so let's try to perform the calculation mentally, because this is not the big calculation. Maybe the question can come in paper 1. So I cannot take 9 from 8. 18 minus 9 is 9. I'm left with 1. 11 minus 5 is 6, and 3 minus 1 is 2. Okay, so 428 minus 159, this is equal to 269. So I hope, students, you are really clear that how we are finding the temperature of the metal bar after 9 minutes. Okay, moving to the second part. That says the total time needed or required for the metal to reach to the temperature of 25 degrees centigrade. 25 degrees centigrade from what temperature? 428 degree centigrade. Let's try to understand the question, that in this part we need to find the total time taken for the metal to reach at the temperature of 25 degrees centigrade from 428 degrees centigrade. So let's try to understand the question once again, that initially the metal, when it was heated, or metal bar, it was heated, its temperature was 428 degrees centigrade, and then it starts cooling down with the fall in the temperature with the rate is the 23 degree centigrade per minute. 23 degree centigrade per minute. Okay, let me see the previous page. Yes, per minute. For what? For how much time? For first 3 minutes. 3 minutes, and then the next is that after 15 and after that at the rate 15 degree centigrade per minute for next 15 minutes. And the next at the rate of 8 degrees centigrade, 8 degrees centigrade per minute until it reaches to what temperature? Temperature 25 degree centigrade. Okay, now we have to find the time when the metal temperature of the metal is reaching to 25 degrees centigrade. So if we observe the information given carefully, that we can see that the information is given that out of this 428 degrees centigrade, for first 3 minutes, okay, 3 minutes, the fall is 23 degree centigrade. Next 15 minutes, 15 degree centigrade, okay, from 428 degree, and the remaining for this portion after 15 plus 3 18 minutes, okay, the rate of the temperature, or the rate at which the temperature is going down, is 8 degree centigrade per minute until it reaches to 25 degree centigrade. So it means that we can easily find the total loss in temperature in first 18 minutes. So loss in temperature for first 3 minutes, loss in temperature in first 3 minutes, in first 3 minutes will be equal to 23 multiplied by 3. Students, I hope you are really clear, because here it's written 23 degrees centigrade in 1 minute, that in 1 minute 23 degree temperature is going down. So in 3 minutes the fall in the temperature will be, or the loss in the temperature will be 69 degree centigrade. And for next 15 minutes, loss in temperature or fall in temperature in 15 minutes, next 15 minutes will be equal to, the rate is 15 times 15, 15 times 15, and which is equal to 225. Let me check the rate once again. 15 minutes, yes, 225 centigrade. So the total loss of temperature in how much time? In 18 minutes. 18 minutes total loss. So in order to get the total loss, what we are going to do is 69 plus 225. Okay, 69 plus 225, we can add them easily. 225 and 69, 9 and 1 10, and 4 14, 6 into 8 or 1 9, 294. 294. Let me check it once again. 69 plus 9 and 1 10 is 14, 6 into 8 and 1 9, 294. 294. So remaining temperature will be equal to, let me write a degree and centigrade. This is temperature, remaining temperature. Try to understand the question, that from 428 degrees centigrade in a total 18 minutes the temperature has gone down to 294 degree. So how much temperature is still with us? That will be equal to 428 minus 294. 428 minus 294. 8 minus 4 is 4, and here 2, I cannot take away 9 from 2, so 12 minus 9 is 3. 134 degrees. 134 degrees. Okay, now look, that after 18 minutes, the temperature is going down with the rate 8 degrees centigrade per minute. and we need to find the time when the temperature has reached to 25 degrees centigrade. So there must be some temperature between 134 to 25. So what we are going to do is that at this stage, at 18th minute, okay, or from from the starting point till 18 minutes, the fall in the temperature is 294, and the remaining temperature that we still have to cool down is 134 to reach at 25 degrees centigrade. So there must be some temperature between 25 degree centigrade as well. So we are going to find the difference between the temperature, that is 134 degree centigrade minus 25. 134 minus 25, 14 minus 5 is 9, and here we are left with 2 minus 2 is 0, and this is 109 degrees centigrade. 109 degrees centigrade. Okay, now it means that the temperature is 109 degree centigrade, the remaining temperature is 109 degree centigrade, and for this remaining temperature, the rate of fall of the temperature is 8 degrees centigrade in 1 minute. 8 degrees centigrade in 1 minute. So if in 1 minute the temperature is falling 8 degree centigrade. So if we have 1 degree centigrade fall, 1 degree centigrade falls, so the time will be 1 by 8 minutes. What is the requirement of the question? Total time. Okay, we need to find the time when the temperature reaches to 25 degrees centigrade. So for the remaining part, the rate is that 1 degree centigrade is falling at the rate 1 over 8 minutes, because 1 degree centigrade is falling in 1 over 8 minutes. So what we are going to do is that 109 degrees centigrade will be falling in what time? 1 over 8 times 109, and now we can leave it as it is, 109 by 8, and we have to find the total time needed. So total time will be equal to 18 minutes plus 109 by 8. Okay, 18 plus 109 by 8 minutes. What we can do is take the LCM. 8 is the LCM. 18 times 8 is 144 plus 109 plus 109, this is 253.8. 3 by 8 divided by 8, that is 31.625. 31.625 and minutes. So this is the time when the temperature will reach to 25 degree centigrade. I hope students you are really clear about today's class, one of the most important questions of your O-level examination. Please watch my lessons, like, share and subscribe the channel, and press bell icon to get the notification of every lesson in time. Thank you very much.